Okay, so I've added a couple notes here at the bottom, some exponent rules I just quickly want to review before we go into doing these ones up here in the section A, D, and E. And so let's go over these exponent rules and make sure you recall all of this information first that we've already reviewed. So first of all, here we go with the add rule. When multiplying the same big base, we add the exponents. So something as basic as just saying x to the power of 3 times x to the power of 7. Do you recall that we just add the 3 plus the 7 and we get x to the power of 10? And likewise, if you have a base of a constant, like 2 to the power of 4 times 2 to the power of 5, we still just add those exponents of 4 plus 5. So the add rule is used when you have the same big base that's multiplying. Now let's go look at the multiply rule. Okay, the multiply, when multiplying a power to a power, we're going to then multiply the exponents. So for example, here, we're going to say something like, what if you had x to the power of 5 to the power of 3? Then that 5 is going to multiply by that 3. So we get x to the power of 15. Let me make this a little bit bigger. And likewise, if you had a base of 2, 2 to the power of 3 squared, you would then take the 3 times the 2, and it becomes 2 to the power of 6. This is called power to a power, or the multiply rule. Finally, the subtract rule is when we have big bases, like x to the power of 11 over x to the power of 3, and then we take those two little exponents and we subtract them. 11 minus 3 would be x to the 8th. So the subtract rule is used when dividing with the same big base. Now, negative exponents, recall that if you have something like x to the negative 3, it becomes 1 over x to the third power. So anything with a negative exponent is going to move locations. If it starts in the numerator, it's going to go to the denominator with a 1 on top. If it starts in the denominator, it's going to move to the numerator with a 1 on the bottom technically, or nothing on the bottom. So x to the negative 3 would equal 1 over x to the third power. Notice when it moves, the negative goes away. So negative exponents are repeatedly dividing, and they just become a fraction. If they start as a numerator, they move down to the denominator. Now, last comment here as just a little hint. I called this showering the power. If you have two things inside parentheses and it's squared, everything gets that power. It becomes x squared and y squared. And likewise, if you have something over something else, a fraction squared, everything gets that power. So we called that showering the power. It goes to all the parts if you're multiplying or if you're dividing. And the same thing happens with square roots. Now, let's go up and look at some of the examples here and see if that little quick review was enough. So here on part A, we've got the big coefficient 3 multiplying by big coefficient 2. Then we have x to the third multiplying with x to the invisible 1, and then y squared times y to the fifth. So here I go old school, 3 times 2 is just 6. X to the fourth from the add rule, and y to the seventh from the add rule. Do you see how that rule was applied? Okay, let's go take a peek at letter D here. This is the showering the power rule, but we're not going to do that until we simplify the inside first. So I'm going to put a little note here. Simplify inside first. So for example, 2/4 just becomes 1/2. X to the third on top with x on the bottom. Subtract rule of 3 minus 1 leaves me x squared. y to the first power over y to the fourth becomes 1 minus 4, or y to the negative 3. And this is all to the power of 3. But remember that anything with a negative exponent wants to go downstairs. It's starting in the numerator, it's going to go down. So I'm going to have x squared on top, 2 on the bottom, and y to the third moves down. Now we shower this power. Everything gets the power of 3. This is to the power of 3, this is to the power of 3, and this is to the power of 3. So final answer is x to the 6th over 2 to the 3rd, y to the 9th. Final answer. How'd you do? Okay, this one over here is also showering the power, where it becomes 3 gets a power of 2, and x to the negative 4 gets a power of 2. 3 squared can be simplified to 9. This gets simplified to negative 8 when I multiply. Remember that anything with a negative exponent wants to move down if it starts in the numerator. So final answer becomes 9 over x to the 8th. How'd you do? Now, this guy up here, letter B, is just a simplifying radical. It means we're going to split this up into what times what equals 32. So hopefully you see this perfect square embedded of 16 and 2. So the square root of 16 is just 4. Square root of 2 is just 2. My simplified radical would be 4 root 2. We've been doing a lot of this with quadratics. All right. We're also going to go over this polynomial ascending order. I actually would like you to change to descending order before we get started. So write in descending order, or greatest exponent down to the least greatest exponent. Descending order. Okay, so I'm looking through these powers and I see that negative 3x to the 4th is my greatest power, so it goes first. Next comes the negative 4x to the 3rd. Next comes plus x squared, then minus 2x's, and then the constant of plus 5. If you'd like to cross out as you go, like 3x to the 4th, negative 4x to the 3rd, plus x squared, minus 2x, plus 5, to make sure you use all the components, feel free. It then says to name the degree of the polynomial. Remember that your degree is the highest exponent, so my degree is 4, or my highest power of the polynomial. Let's pause the video here and go do letter B and then see how you did. All right, check this out. Let's see how you did. I hope you started with negative 9x to the 4th. And then there's no x to the 3rds, so I go into plus x squareds, and then plus 3x's, and then minus 6. And I've used everything now. And then my degree of the polynomial, which is the highest power, is again 4. Yes, there will be ones that are that easy on the test.